Okay, so we are going to talk about annex cam today. So we are going to perform an operation. Okay, that is basically a milling operation. We are going to basically perform that floor and wall operation. Okay, and we are going to extract that part program also. So let's start. So we are going to click on that new to start the software. So this is your annex. It's a cement tool. So we can basically do that CAD as well as CAM and your CAE part also in this software. Okay, it's a very used tool. So it's a complete solution for manufacturing field or research and development or product design and analysis. You can do all parts inside this software. So today we are going to discuss about that CAM. So just you can choose that units from here, and after that I'll go to that model. First of all, we need to insert that model. You can give that up name to that model from here, and you can give that location. So just click OK to enter the part modeling. So here we are going to import the model. We are not going to take the time for modeling part because we are going to only talk about that manufacturing today. Okay, we are going to do that mill operations, that is floor and wall. So we will just go here, and even you can see here that models are present over here. You can pick it from directly from this space also, or you can directly open and bring that. So my component is located in this cam folder, and just click here. You can see this is the file we need to import. So just import it. So yeah, this is my component which I want to manufacture. Okay, so this is going to be that area which I want to cut with the help of milling operation, that is wall and floor. So here if I talk about the walls, these are going to be that vertical walls over here on the sides, and this is going to be the floor. So directly I'll enter that application. I'll go in that manufacturing. So when you'll come to that manufacturing, it's going to ask you which machine you want to work. So here cam general is basically is going to be that cam session configuration. We are going to select that cam general, and in this basically you can select the machines. Here we are going to go with the milling planer. Below it there are multi-axis conveyor operations. Nowadays rotary work basically is very much in trend, so you can go with that rotary operations also. Here it is hole making, that is drill operations, and this is your turning. Right now we want to work on that mill planner, so just do it. Okay, so you can see here your window basically is now totally turned to manufacturing. So first thing what we need to do is going to be very important. Okay, just I'll go with that front one. You can see the coordinate basically is at the base of this component, so the tool is going to not start from here, so we need to change the MCS first, that is coordinate system. Okay, we need to bring our Z direction over here or above the job. Okay, otherwise what is going to happen, the tool either it is going to break or that job is going to damage. So you can come here and you can check MCS is there. You can just double click on that MCS. Now it will give you the direction you want to move your coordinate. So I'll just want to move that Z direction. I know the height of my component, that is 25 mm. So just I'll write 25, and you can add some more stock material also inside it. I'll just add 25 and enter. Now you can see that coordinate has moved on the top of that component, and do it. Okay, my component is okay now. So I'll change that view. You can right click and also change. Basically you can fit your component. You can go for that isometric from here. So second is I need to tell to my machine that which is my workpiece, on which workpiece I want to work, what is my raw material basically. So double click on it, is going to ask you specify the part you are going to machine. Just click on this, tell to the machine that yeah, this is that product I want to manufacture. After that is going to ask you raw material. Okay, so in that shop you will go and bring a plate like that for manufacturing this shape, So we need to give that raw material to it. It's basically we need to give that bounding block. It's basically a rectangular block, so we need to give bounding block. If we are working on lathe, you can go with that bounding cylinder. So right now just click on that. Automatically you will see that raw material is assigned to it. And if you want some stock material, okay, you want to add some material in any of that direction, extra material, so you can just put over here or you can directly add it over here. Okay, right now I don't want to add, so just do it. Okay, so two things I have done. And whenever you are going to complete that operations, you are going to say, you can display, yeah, this is my raw material, this is my blank. Just do it. Okay, so we have set our coordinate for the tool, and we have told to that machine we have created our raw material. Now we need to create a tool. Okay, so we need to create a tool. So here there is a library, and some of the tools are available on that front face also. So what we need to do, just double click on the library. After that I want to create a milling tool, that is a cutter, and the dia of my tool is going to be 12 mm. After that just click OK. What's the good thing is that now that tool is going to bring all the 12 mm end mill dias. Okay, that tools over here in front of you, you need to choose out of it. So I'll choose that first one, that is 12 mm end mill tool. Okay, so just do it. Okay, after clicking it you just cancel it because the tool is assigned. If you want to check the tool, you can just click here, and you can just check out here. You can see your tool is basically showing over here, and even you can change your tool direction. Okay, you can just click and bring your tool upside or any of the direction. So right now I don't want to do that, just click outside. Now the most important thing is that operation, create that operation. So the operation is going to be your floor and wall operation. I just told you this is my floor and this is my wall I want to manufacture. So that operation is already selected. Now we need to give in program where you want to save your program. Here need to give the tool which we made, that is a 12 mm and mill dia. After that the geometry. Okay, so geometry is my workpiece. We told to that machine it is a workpiece. So what type of operation you are going to perform, either it is a finish operation or a rough operation. I am going to choose mill rough operation, and after that just do it. Okay, you are going to click OK. You are going to get the floor and wall operation parameters. Okay, so almost that geometry specify already, that part is specified. Now the most important thing is, first operation we are going to work on cut area floor. Okay, we are going to work on the floor first. So we are going to tell the machine that up to here we are going to cut. We are going to select here and just do it. Okay, after clicking this, what we need to do is we need to tell what is going to be the pattern of tool. Okay, so right now what I'm going to do is that you can either do zigzag also, on the both sides it's going to cut the material, but I'll tell it to follow the part. Okay, because the tool is going to travel very less in this sense. Okay, otherwise the tool is going to come to that retract position and back to that start position, so it's going to take a lot of time. So I'll take that follow part. Now this is your maximum distance, this is that tool percentage. Okay, so up to 60% we need to take that tool, how much the tool is going to be used. So here that is asking floor blank thickness. Okay, what is that floor blank thickness? I know up to here we have to cut that material, so that thickness basically is 15 mm we need to cut. And after that we need to define the depth of depth per cut. Okay, depth per cut is basically out of 15 mm how many cuts you want to give. Okay, how many term. So normally either we are doing that rough operation or finish operations, we are going to give like 0.01 or very less. Okay, because we need to see what is that material of the job, and how much the tool is capable to cut the material. So right now it is a software, so I can give it like 5 also, so that machining time is going to be at lesser side. So it's going to cut like in 3 times. Okay, 5 into 3, it's 15 total. Okay, so next thing which is very important, you can set the cutting parameters, and it's a rough operation. So in this you can see the stock material automatically 1 mm is going to be there. It's going to be like on walls, it's going to leave 1 mm, it's default. You can change also according to you, zero point 0.5 or 0.1 mm you want to see. So the most important thing, that is your feed and speed. So here I am going to define two things only, that is your surface speed, that is 95, and then we are going to define the feed per tooth. Okay, that is 0.09. So after doing this, now that machine, basically that software benefit is that it's going to calculate itself the spindle speed and your feed rate. Okay, just click on the calculator. You can see according to the surface speed it has taken the spindle speed and feed rate, and after that just do it. Okay, after defining these all parameters for that wall, what we need to do, sorry, for the floor, we need to just generate the operation. After generating that operation, you can see that tool is going to travel like this. Okay, so in this case you can even do like follow zigzag. Okay, zigzag is basically like coming direction also material is going to be cut, and during that the tool is going to come back, it's going to come that material. So again I'm going to generate. So now you can see this is known as your cutting pattern. Okay, so now I want to see it how it works. So I'll just go here and reduce the speed of machining, and you can just play. See, now you can see on the walls 1 mm material is left. Okay, the floor is absolutely fine, but walls are still left. So we are going to perform that wall operation also. Before that, we need to check what? We need to check the part program for it, G codes and M codes. See, that program which basically that CNC programmers do manually, it's very tough. Okay, there are going to be lot of human errors for that big programs or complex components. So here it's very simple. I've done this operation, I want that part program. Just click on that post process. It's going to ask you on which machine you are going to be working. It's my simple mill 3-axis, and here you can choose the post process, that is your operating system. It's going to be Fanuc, Siemens or something else, so you can choose it from here. So I'll just do it. Okay, okay, now that part program is going to generate. You can just save this program at the desktop. I want to save, just give the name, just like you can write floor, sorry, floor. Okay, so what we need to do is just save in that text document, and on desktop I'm going to save it. Just save it and close it. Now you can say a tick mark is going to come that yeah, operation is finished. And even if you want to check that, go here and just, this is my floor program on the top, just double click on it. This is that program. Okay, so you have to just put it in that pen drive, and then directly you can copy to that CNC machine and execute the machine. Okay, so from it's going to start from here. You can initial these basic things you can delete, so you can save it now. Okay, you can save this program and directly you can import. So this is only for that floor. Now what I want to do is I want to perform my wall operation. Just copy this operation, right click, and again you need to post it. Just double click on this. So obviously here what we need to define, we need to define the, even you can change the tool for the walls. Okay, but right now I am going to take that same end mill tool for the same diameter of 12. So here we need to specify the walls. Just click here, manually I'll select these are my walls and just do it. Okay, after defining my walls, what we need to do is we need to choose like it's my finish operation, it's mill finish, Even from here you can change your tools and other things. The library is present over here, create new tool, but I'll go with that same tool. It's not going to harm me. So obviously this is my cut region, that is floor. So you can check it like walls over here. Cut region is containment is going to be walls. After that movement of tool is going to be like follow part. Okay, this time I'm going to take follow part for the wall operation, and this is going to remain same as the thickness is 15 mm, and in 3 cuts it's going to cut. Speed also let it same. So almost the things I've done. So just generate your, so you can see the tool is traveling a lot. Okay, what we need to do is just first of all click on that floor, and then you can choose that profile and again generate. Now can you see that tool is only going to move at that side. Okay, it's going to cut that time, otherwise it would have moved on that floor part also, and then in at that end it would have reached to that walls. So no problem, now we can check that, and you can just play. Okay, that speed was quite very fast, so virtually you can see now I have done that speed less, but yeah, material is cut, so it's going to cut in 3 times. So just do it. Okay, now just do it. Okay, and you can go with again the same post process of 3 axis milling machine. You'll get a part program over here, and you can save it like on desktop. It's going to be my wall. Okay, and just save on the desktop and close it. Now I want to see both that machines simulations, so you need to just control and select both the programs. Okay, and simulate the machine. Here you need to see the cut the material, how it's going to cut the material. Now you can reduce a speed quite more and then play. So it's little bit a graphic issue, so you can see I'll just do that speed quite faster. Now it is okay. Okay, it's going to come back, and again in zigzag it's going to cut that material. I told you it's going to cut in that 3 cuts. It was 15 mm and one cut was for 5 mm. Normally we don't do it. It's basically wall operation and the last cut. Okay, and here one more thing you can do is you can close it. Now together also you can get a post process. Okay, you can get all that part program. Okay, now this is a combined one. Floor and wall both operations are going to be at same time. Okay, you'll get a part program out of it. Now if I want to see actually there are 3 type of that machine badge. Okay, when they basically perform, and that is your head to head, head to table, and table to table. Okay, that is basically that rotations and movements. So that are the type of machines. Okay, that are horizontal and vertical milling machines. So it contains that. If I want to see those things and I want to work particularly on that machines, you need to select those machines from here. You can see even it's going to tell you about the operating system and the machine. So here what I'm going to use, Siemens 3 axis milling, and you can see here vertical. I'll just show you that thing is going to be very important. See, that is table post. Below you'll go, that is your head post, head, table to table. Okay, there are various. So whatever that work on that machine you are going to work, multiple axes are going to be like table to table and other ones. Okay. Right now on this machine, just do it. Okay. You want to mount what is that positioning of your workpiece? I'll mount it on that junction. Okay, just do it. Okay, on the same coordinate. After that just close this. You'll see your milling machine is going to be there in front of you, and the job is going to be aligned over there, and you need to do okay and simulate that machine, and you can now just fastly run that program. Can you see now? Okay, so this is basically your horizontal milling machine, huh? So that, like that also you can work on it. So that was all. So somebody who needs guidance or the training on this particular software, so I just let you know that when you talk about NX CAD, that basically contains a lot of things inside it, just like sketch module is there, your part modeling is there, that is known as 3D modeling, your assembly is there, sheet metal is there, surfacing is there. When we talk about surfacing, it is connected to reverse engineering part also, we do on reverse engineering also. After that, finally detailed drawing. Detailed drawing contains that geometric dimensioning and tolerance part, and where that complete detailing of the drawings is done in that orthographic with dimensioning and tolerance. Okay, so that is that CAD. And when we work on CAM, no, basically that our company is providing on CAM, we are working on mold design, mold flow analysis. One is that most important specialization part in industry. After that, I told you reverse engineering, we are doing on that complete part. We don't do scanning. After that scanning models which come to that company, we basically work on that meshed file and create them 3D models. And last one, which is very important, that is CNC program, or you can say that computer aided manufacturing. In that, on the various operations of lathe, milling and drill, we perform on this softwares. Okay, and for CAM, no, we basically have almost like three tools for mechanical engineering. One is NX CAM, one is Power Mill, that is a Autodesk product, and third one is Master CAM. So these are dedicated tools for computer aided manufacturing. Okay, so if somebody wants any guidance regarding these tools or trainings, so below that I have kept an Google form, you can fill that, you can put your details, our team is going to contact you and tell you about whatever your query is. Okay, so thank you for watching the video.